دكتور.
In problem 1, using Jacobi method gives the solution of the following system after 7 iterations. What can you conclude from observation of the results? Take as initial guesses x equals to y equals to 0. So here we have a system of equations and we want to solve it using a Jacobi method. Okay, if they don't tell you to make the matrix diagonally dominant, don't go over that. So just work with it as it is. Sometimes even it's not possible to make it diagonally dominant. For example, here, if you look at the first equation, the second, the diagonal term, which is 2, is smaller than 5. So this is not satisfied for this equation. So this equation should be equation 2 in order to satisfy the diagonally dominant condition. But in equation 2, this coefficient 1 is smaller than 2, so this equation is at its place. So here, if you pivot these two, equation 1 will now be at its right place, but equation 2 will be at its wrong place. So here it's not possible to have a diagonally dominant system. And we can say then that we might have convergence or not. So convergence is not guaranteed. But in case we have a system, and when we switch the equations, we are able to get a diagonally dominant system, then we are sure that it will converge. Okay? If I want you to have a diagonally dominant system, I will tell you to rearrange the equation to be diagonally dominant. If I don't tell you anything, work with the system as it is, okay? And take the first equation to get x, the second equation to get y, or if we have x1, x2, x3, the first equation to get x1, the second equation to get x2, the third equation to get x3. It's possible to switch, but in order to obtain the same result, because we are working on same method, then we'll always take the first equation for the first variable, the second equation with the second variable, because if we switch, we will have different results. This is due to round-off errors, okay? So now, from the first equation, we can write that x is equal to 21 minus 5y over 2. And from second equation, we can write that y is equal to 8 minus x over 2. Now, since they are asking to use Jacobi method, keep in mind that you don't use updated value within the same iteration. So when you calculate x1 by replacing now y by 0, when you want to calculate y1, you don't use x1, you use x0. Because we don't use, in Jacobi method, we don't use updated value in the same iteration. No, once we finish for all variables the calculation, we update, and we use the update in the second iteration. So here, when I want to calculate x1, I use y0. When I want to calculate y1, I use x0. And then I say I will update x1 and y1, then move to the second iteration. In the second iteration, to find x2, I will use here y1, and to find y2, I will use x1. So I update my values from iteration to iteration, not within the same iteration. Okay? Now, here they ask to stop after 7 iterations. So this is the criterion to stop my solution. And I want to look at my result to try to make a conclusion. So let us see what do we have. So for the iterations, you will proceed step by step, first, second, third, fourth, fifth, sixth, and seventh. So of course, every time, so in the sixth approximation, you will use for y and x the values of the fifth iteration. And in the seventh iteration, you will use values of the sixth iteration, etc. Okay? Let me check your questions. So now, after conducting all of these iterations, we can summarize. Yes?
بس في شوف first iteration
Yes, sure.
فوق الأول.
This is the first iteration. In the first iteration, you replace y by y0. You replace x by x0, which are 0, 0. So you get x1, y1. Once you find them, now in the second iteration, in the expression of x2, okay, you should use y1. y1 is 4. So you replace y by its value at the previous iteration. And now in the equation of y2, you will use the value of x1, which is the following one, 10.5. So now, to calculate y2, you will use x1 equal to 10.5. Now you have the new values x2, y2. You will move to the third iteration. Now in the third iteration, in x equation you use y2, and in y equation you use x2. Okay, etc. Is it fine, Serge?
Yes دكتور، بس كان بدي أشوف الفاليو عندي إذا كان صح.
Okay. Now, in order to make conclusion about the results, we should observe how the value of x and y are evolving with iterations. So what we can do, for example, we can draw for x the variation of x with iteration. So let's say for iteration 1, the value was 10.5. So the value, let's say, was here. So let us consider, you can make a small scale. So since the maximum value is 23, so let's say this is 10, this is 20, okay? So for the first value, you are nearly here, 10.5. Then for the second iteration, you drop to 0.5. And for the third iteration, you have another jump to a higher value, which is 13. So it's nearly here. And then at fourth iteration, you are back to down values. So it's 1.125. Then you jump again to a higher value, which is nearly 17.5. And then you drop to 1.9. And then you jump again to 22.5 nearly. So if you draw the variation of your values, you have oscillating behavior, and not only oscillating behavior, the amplitude of oscillation is increasing. So sometimes you might have an oscillating solution, but at the end it will be convergent, because with time, with iterations, your oscillation will damp out. However, here what is happening is that with iterations, my oscillation are increasing in amplitude. So this is a divergent behavior.
Doctor, يعني it might be oscillating but convergent.
Yes, if it's
Okay.
like this, if it's like this, for example, let's say it's
Yes.
like this.
وما فهمت how we plot the values يعني عند x y.
No, I'm plotting just x, the variation of x with iteration. So this is x, this is I. That's it. And I'm plotting the values. This is for I equal 1. This is x1. This is how I'm plotting. Okay? For iteration
Yes.
2, I'm plotting x2, etc. Also, if you look at y, also it's an oscillatory behavior, but it's more dominant for x. So whenever one of the two is divergent, this means that the solution is divergent. Okay?
دكتور لو الامبليتيود كان عم بيقل كنا بنقول انه converge.
ما فينا نكون اكيدين انه converge، بس انه it might end up with a converge solution، لانه اذا ضلت تخف yes it will converge at the end. اوكي يعني it will بالاخر بيصير الاوسيليشن very if you want very الامبليتيود تبعهم very small. If you remember وقت اشتغلنا على الترو ايرور والابروكسيمت ايرور، شفنا الترند مثلا للترو ايرور بالبايسكشن ميثود، شفنا انه الترند is like this. صحيح we have oscillation but the overall pattern is decreasing. So if you have an overall decreasing pattern, you can say that it's a non-monotonic convergence, but it is convergence. And we call it then non-monotonic convergence. I mean, we have oscillations, but at the end we are converging to a solution. While here, with time, with iterations, your amplitude of oscillations is increasing, and you are getting farther and farther from a certain solution. So in this case, it is divergent. Okay? Any other question on this?
دكتور إذا كانت السيستم فينا نعملها diagonally dominant matrix
بنكون
بس أنت ما
sure.
قلتي إنه
Yes. لحظة بس 1 second حسن. إذا هي شو؟ إذا هي diagonally dominant. Can you repeat please the question? Mom, قطعت. Do you hear me?